The graph of a function f is the set of all the points x and y in the coordinate system such that x belongs to the domain of f and y is a value of function at x. Now let's consider particular example. Let f of x be a function x squared minus 2. Now if x is equal 1, what point is on the graph of f? X equal 1 is in the domain of the function f, because the domain of the function f is all real numbers. Therefore, to find the point on the graph, I have to compute the value of y that corresponds to the x equal 1. So y is equal f of 1, and f of 1 according to the formula will be 1 squared minus 2, which is negative 1. And that means that the point 1 and negative 1 is on the graph of that function. So we have 1 point on that function. Now the question is, how about other points? Do I know whether, say, point 1, negative 2 is on the graph of the function or not? How will I know that? And it is good here to remember that the point is on the graph of the function if the y-coordinate of that point is the value of function at x-coordinate. So if I have the point 1 and negative 2, this question can be rephrased, and instead I could ask, is negative 2 or y-coordinate the value of the function at the first coordinate? And the answer to this question is no, because we already computed f of 1 to be negative 1, which is not negative 2. So how do I plot all those points on the graph? How do I sketch the graph of a function? We can't plot all the points, especially when the domain is as large as the set of all real numbers. So what we'll do is we choose some points, plot those points, and connect the points with a continuous curve to see what the graph is. The more points we have, the more accurate graph. So let's choose the points in the neighborhood of the origin, and we'll use the integers as the values of x because these are the easiest to compute the values of y of, as well as plot in the coordinate system. So if x are the values negative 3, negative 2, negative 1, 0, 1, 2, 3, and we know that the function f of x here is x squared minus 2, to compute values of corresponding y's, I need to square the input, square the x, and subtract 2. So the first value is negative 3 squared minus 2, that's 9 minus 2 is 7. The second will be negative 2 squared minus 2, which will be 2. In the similar way, computing these values, we'll get negative 1, we'll get negative 2, negative 1, 2, and 7. And the corresponding points are going to be negative 3, 7, the negative 2, 2, negative 1, negative 1, 0 and negative 2, 1 and negative 1, 2 and 2, and 3 and 7. We plot those points in the coordinate system, so negative 3 and 7, negative 2 and 2, negative 1 and negative 1, 0, negative 2, 1 and negative 1, 2 and 2, and 3 and 7. Now those points were plotted in the way that x increases, and that's how we'll connect those points. So from x equal negative 3, we'll go to the point where x is equal negative 2, x equals negative 1, 2, and then through x equal 1, x equal 2, we'll continue to x equal 3, and we obtain the graph of that function. So this is the graph of the equation y equals x squared minus 2, or the graph of the function y equals f of x.